Okay, ladies and gentlemen, what we're going to do here is we're going to go over some of these examples that were on this set of notes. We're going to actually try to complete some of these examples. What I'm going to complete is the hypothesis testing about a proportion for a large sample. And that's the first section of these hypothesis testing questions. So, okay, let's kind of go through this and let's see how this works now. As an example here, this is what I would say. You simply read this. You're going to do a lot of reading. And you see that it says the proportion here of college students who take a full load, and then that's at least 12 units, is not 40%. Okay, so I read this, and then it says, by the way, as claimed by somebody, whoever. Somebody's going to make a claim. And I typically put that phrase there so that you guys can know automatically when you translate that statement. P here is not equal to, the 40%. So write that down somewhere. P is not equal to 40%. Now that's going to be your claim here. So I want you guys to definitely figure out the claim. And on a test, that's going to be the first question I ask. What's the claim? And so you go, oh, the claim is that the proportion here is not equal to 40%. So that's the first thing I ask. Now, in your hypothesis testing procedure, right, this information, the first step is to always set up your hypotheses. Notice what I call that. This is the setup portion. And that's the first step. So the fact that this is a not equal means that the claim happens to be an alternate hypothesis. So I put this in the alternate hypothesis position. And here's that claim. So my claim is an alternate hypothesis. It lacks a condition of equality. So the opposite statement to that is that the proportion actually is 40%. So these two statements always need to be the logical opposites. So you have not equal and you have equal. So this is a hypothesis testing question about a proportion. So this is setting up the hypothesis. I labeled what the claim is, though. And what you're going to do now is go back over here. This is what I want to remind people of, that when it's not equal, you always look at this alternate hypothesis. That says it's going to be a two-tailed test. And this is why you see two tails here in the decision rule. Okay, so not equal as an alternate hypothesis always gives you the two-tailed test. It's in the format I gave you in that summary. Here is a summary of what we're talking about. That's that two-tailed test. Not equal, we look at that. This is your decision rule. And we set up the hypothesis. I'm going to do that here. And this is our decision rule. So I want to remind people that's a summary. And remember, I say label the hypothesis, label the claim. And we did, because that's going to be a part of our conclusion here. So just going through the notes here about this procedure for you guys. So we already did the first one, so we're going to see the second one here. And now let me remind you guys here, what comes next when you read this is they're going to give you the sample information. They're going to say a sample of 420 college students reveal 172 are enrolled in a full load, at least 12 units. That's a full load. So we're really not done with the decision rule, because when we read further, it says use the 10% level of significance here. And that means that alpha here is 10%. So if it's the sum of the tails, 5 and 5, notice, makes that 10% level of significance here. So everything's on par. Now, for the 10% level of significance for two tails, what I went over earlier here, if we go all the way back to the two tail summary here, this is what I want you guys to remember. Make sure you have these in your notes. 10% two tails. Right? 10% two tail is right here. Here's the alpha. 5 and 5 makes that 10. Notice your critical values are negative 1.645 and positive 1.645. So this is your critical values. You have two of them. Negative 1.645 and positive 1.645. So if you said, is this why in your decision rule here, so you kind of have these training wheels, if you want to think of it that way. This is why I have your critical values again, if you guys remember, here and here. So these are the critical values. And on a test, I'm going to ask you also for the critical values. You have two. So this is going through the procedure. We now really have our decision rule, and we're now ready to take a sample. And I write down the sample information. Maybe we should put it over here. And say, okay, what did they say for the sample? They told us that a sample of 420 college students, 420, revealed that 172 enrolled in a full load, 172. Okay? Now that's all the information we get from the sample. Since this is a hypothesis test about a proportion, though, we're going to need that sample proportion. So it's 172 divided by 420. So the sample proportion will be here. We got to get out that TI. $172 divided by 420. So we're going to approximate to the nearest thousands here, 0.40. It's not 9 because the digit to the right's a 5. So we add 1 to 9 and we get 10. So this is 0.410, 0.410, ladies and gentlemen. 0.410, which is going to be 41%. Okay, so here's my sample proportion. That's why we take a sample, we get that sample proportion. Now, all of these questions in the beginning here about a hypothesis test about a proportion here. Okay, and it's a large sample, but okay. So we have to use, at this point, a test statistic now. We're going to see, based on this sample, we're going to compute a test statistic based on the sample. So you say, was that in the notes? Yes. Take the sample. We did compute your test statistic. Now, the one we're focusing on is right here. This is your test statistic for a hypothesis testing question about a proportion. Okay, so look at the details here. The sample proportion and the sample size come from the sample. So I'm going to code that red. P, this is the same P. And 1 minus P is the complement. That comes from the hypothesis. So I'm going to need to use this formula because this is a hypothesis test about a proportion. So now you go, okay. The best way to memorize a formula is every time you use it, you write it down. That's the best thing you could do. And it's good to do it, because if you take a test, following a consistent procedure will help in easing your nerves. So I look at that and go, okay, I'm going through my procedure here. I'll even say, sample proportion, sample size. We computed that already. 0.410. Sample size was 420. And then P is up here. P is 0.4. That's 40%. So I'll replace that with 40%. 40%, and 1 minus 40%. So this is going to be where 40% goes. I always rewrite this because as you guys can see here, if you don't, it gets hard to see what's actually there and what isn't there. And now say here's 40%, and I know the complement of 40% is 60%, so I'll write it down automatically. So the 40% here goes here, here, and here, which is here, here. There's the complement of 40%. And remember, when you enter this in the calculator, put it in such a way, you're going to put the parentheses around the numerator and divide by the square root of parentheses around this denominator. That'll help us with our calculator work. So when we compute the test statistic, we want to approximate it to the nearest place value of your critical value. So that this is going to be the nearest thousands here. So we're going to approximate that test statistic and see where it lives in our decision rule. So in the TI now, we'll say parentheses, 0.41 minus 0.4. Close that, divided by the square root, open the parentheses, 0.4 times 0.6 divided by 420, and close this. So double check to see if we entered everything okay. And you get 0.418 to the nearest thousands. So it's 0.418. That's your test statistic value. Okay, so they've got the test statistic, 0.418. Now, 0.418, ladies and gentlemen, if we go to the decision rule, because now after you compute the test statistic using that formula, we have to state our conclusion. So our conclusion is either going to be one of two statements. The sample supports the claim, or the sample does not support the claim. It's going to be one of these two statements. So what we need to do with this number, we got to see where it lives in our decision rule. So let's take a close look at this decision rule. Any test statistic that lives between my critical value of a negative 1.645 and a positive 1.645, we do not reject the null. So essentially, not rejecting means you're going to keep the null. And any test statistic that's outside, meaning larger than 1.645 or smaller than negative 1.645, we will reject the null, get rid of the null. So you have to know about your real number line, meaning 0.418 is positive. It's to the right of 0. But 0.418 is not quite past. Here's what the test statistic could be. It's not past 1.645. So that's where negative, or this positive 0.418 would be, I guess. Somewhere like that. And so it's in the do not reject the null. So you keep the null. So don't reject the null based on that test statistic. You keep it. So what I go back and do is I go to the null and I say, guess what, null? You are kept. Do not reject the null. You know, so I sometimes write it down here as a middle step. Do not reject the null, but that's not my conclusion here. Okay? We got one or two statements to conclude. Either the sample supports the claim or the sample does not support the claim. So remember what I said earlier. And this is a very important detail. This is the final place where people have trouble, the conclusion. Label which hypothesis is the claim. So go back to this picture. A picture is worth 1,000 words. If I do not reject the null, I'm keeping the null. Notice what it means about the claim. The claim is out because I'm not rejecting the null. And so what this conclusion really is, here's the final thing that we want to know. Here's the conclusion. That the sample does not support the claim. So your sample is not supporting the claim, ladies and gentlemen, because you kept the null. So keeping the null means the alternate is out, and that happens to be the claim. That's why you label it. So here's an example where we say the sample does not support the claim, and that's counter to the example we worked on earlier, which is what you see in your notes. So here's the second example here for you guys, and I wanted to go over that. And we'll go over some of the rest here. It looks like we're running out of some space, but that's okay. And I want to remind you guys about this particular question here, because it's kind of similar to how the book works sometimes. Oh, let's read this one. Let's read this phrase. This is different. At least 64% of college students believe Bigfoot is real, as claimed by sociologist professors, blah, blah, blah. Okay, so there's a claim there. So you go 64% at least. Remember, 64% is a percent. It's a probability. It's a proportion. So just that phrase, it's a little awkward. They go, at least 64%. So what that is that the probability is greater than or equal to 64%. Now, 64% as a decimal is 0.64. So this is what they're trying to say, because at least is greater than or equal. Now, this again is the claim by some sociologist professor. So the second, that's the claim. So the first question I'm going to ask people on a test is, what's the claim? The claim is that the proportion here is greater than or equal to 64%. Remember, this claim here is a null hypothesis. So I'm going to put it here in the null hypothesis position. And I'm going to not forget to label that claim. So label it the claim. We have to know which is the claim. And that's the claim. Now, here's what's important here, ladies and gentlemen. We need the logical opposite. So the logical opposite of greater than or equal is less than. Okay? What's opposite? Greater than or equal means it's larger or the same as. The logical opposite is less than. So, you might say, Mr. Judge, if it says at least, let's take a look. This is not, ladies and gentlemen, a two-tailed test. So let me show you guys this. Be careful. What does that mean? Remember, this is what you're going to go through, ladies and gentlemen. You're going to go through this process. So if we overlook that phrase, at least we made a mistake. So double check here. This alternate hypothesis tells you what kind of test you have. The alternate hypothesis is less than. That means, and look at the direction, this is a left tail test. So it's pointing to the left. And it's all because they use the phrase, at least 64%, and it's not like the prior phrase that didn't have that. They just said the proportion is not. Okay, this is at least 64. So that's a left tail test. The alternate hypothesis is what you look at. So I like this, even though there's a typo, I like it, because what you'll be doing on your homework and on your test is drawing your own decision rule like this. So I kind of like it. I kind of regret putting decision rules personally, because you would say on homework, oh, that's a left tail, so you're going to do the left tail test here. And this is kind of the whole idea. And you go, okay, this region here is do not reject the null. And this is the reject the null region. 0. This is a z value. We're not done with the decision rule, because what they're going to say here is use the 1% level of significance to test the claim. That means 1% is in the left tail. We need your critical value here. 1%, we need that critical value. Maybe let's label it CV. It's going to be negative, so I'll put the negative sign. So if alpha here is 1%, and this is really a left tail test because of that phrase at least. Oh, they put the at least there. We got to go back. We got to look at our notes. Remember what we said for a left tail. Yeah, I guess it's further up. Left tail 1%. Do we have a left tail 1%? This is what I'm saying. You would either go back and look at your notes here, or you would deduce it by working backwards in your Z table. Here's the 1% left tail test. The critical value here is negative 2.33 here. So good, negative 2.33. So we have a good example here, negative 2.33. And that goes right here. So they can say, oh, would I have to put this here? Yes. So on a test, what I'm going to ask is, what's your critical value? And the answer is negative 2.33. So you have the decision rule now, ladies and gentlemen. It is not a two-tail test. Get rid of that, because that phrase at least. So this is not a two-tail test. It looked like one, but it isn't. So get rid of it. But this is the hard part. You set up the hypothesis. You created your decision rule. You now take your sample. And so in the sample, we're just going to read and see what that means. The sample here, let's read. A sample of 400 college students. 400 college students? That's my sample size. Reveal 252 believe in Bigfoot. Those are the successes. That's X. So we can write it as N and then X, or X and then N. We asked 400 college students. We had 252 believers in Bigfoot. Those are our successes. So the sample proportion is 252 out of 400. We're going to approximate this to the nearest thousandths, ladies and gentlemen. So let's look at the sample proportion of believing in Bigfoot. So here we go. 252 divided by 400. And ladies and gentlemen, this is 63%. So 0.63 here is the sample proportion. 63% of the sample believes in Bigfoot. And that's why we labeled 63%. All right. What comes next is the test statistic. So you're going to use the test statistic formula. Sample proportion minus the true proportion over square root P 1 minus P over N. So we know the sample proportion is 63%. The sample size is 400. So we got those two. This is from the sample. P, though, you say, what's my P value? Go back to your hypothesis setup. You see, when they say this phrase, P is greater than or equal to, right in here, it's the claim, but that means P is greater than or equal to 64%. P is greater than or equal to 64%. There's your P. So you'll put 64% right here. And you'll put 64%. And you'll put 64%. But let me remind you, I always write it down again. 63 minus 64. Square root P. 64. Now, you might say, I don't know what the complement of 64 is. Okay. Just make sure in your calculator, I'm going to do it a little differently. Take a look at the details. Here's my sample proportion and my sample size. Here's P, and here's P. So I can enter this all in the calculator this way. My test statistic value. Okay, so I guess we're running out of space. So I'm going to put the test statistic value approximately right here. We're going to round to the nearest hundredths because the critical value is to the nearest hundredths. And this is where we use our calculator. Parentheses. 0.63 minus 0.64. Go back. 4. Close that. Divided by. Second. Open this parentheses. 0.64 times. Now put another open parentheses and put 1 minus 0.64. That's the Q. Okay, close it. That's P times 1 minus P divided by the sample size of 400. Now make sure you close that parentheses again and come out of there, I guess. So you can enter it all this way. So double check to see between the iPad and what you have here and the TI. Hit enter. So the test statistic value is negative 0.42 because that, ladies and gentlemen, negative 0.42 is going to be the nearest hundredth position, negative 0.42, because your critical value is also to the nearest hundredths position. So the nearest hundredths. So in the iPad, negative 0.42, let's look at the decision rule. This is important here. You got to know how to read this real number line. Any test statistic that lives that's larger than negative 2.33, do not reject the null. It has to be bigger than that to not reject the null. If the test statistic is smaller, it's to the left of your critical value of a negative 2.33, then you reject the null. Now, the test statistic, I guess we have to move it. Let's move it. Okay. Negative 0.42, while it's to the left is 0, and it's not quite past, ladies and gentlemen, it's not quite past the critical value of a negative 2.33. It's somewhere over there. That's negative, if you want, 0.42. So the moral of the story is it's in the do not reject the null. So I write that down. Do not reject the null. And then I think, what does that mean? That means to keep the null. So if we're not rejecting, do not reject the null, because our test statistic is in the do not reject the null neighborhood, you're going to keep the null. When I go back, what am I keeping? Here you are, null. I'm keeping you. You are kept null. Do not reject the null. Do not reject it. You keep it. What does that mean now about the claim? Remember, there's only two solutions. It's either the sample supports the claim or the sample does not support the claim. Since we're keeping the null, which happens to be the claim, the sample supports the claim. And ladies and gentlemen, this is how you handle this one-tail test. So as you guys can see, you need the critical value for the decision rule, and that's what we went to look and work on in the earlier video. So, you know, I have that in your notes. This one, the phrase is at least 64%, so it's not a two-tail test. It's a one-tail. And again, it's a left tail because you always look at the alternate hypothesis, and that's pointing to the left. I'm going to get rid of this. All right. So, ladies and gentlemen, take a look at what this says now. This is another hypothesis test, but it's about another proportion. Let's see if the decision rule is correct. Let's double check. It's always good to go over these. I could double check, so it's fine. The proportion of college students that take 4 years to complete a bachelor's degree, and you say, what are they saying, is no more than 12%, is not more than 12%. And that's, again, a claim by campus researchers. Okay, somebody made a claim. So when you say proportion, you're going to say P. Now, what does it mean to be no more than? So P is no more than 12%. 12% is 0.12. No more than, ladies and gentlemen, is less than or equal. So this is a less than or equal. No more than means 12% or less. And again, this is the claim here. So we're going to see if this is correct. Okay. You set up your hypothesis. You look at the claim, that's a null hypothesis. So I'm going to put that in the null position. So you know what I'm going to do? I'm going to move it because I can. So this is the claim, and it's a null hypothesis. I'm going to put it right there. Okay, there's the claim. It happens to be a null hypothesis. Remember, if this is less than or equal, the logical opposite will be greater than. So this is the proportion is greater than 12%. Now let's be careful here because I want to distinguish between which hypothesis is the claim and which is not. So I'm going to move that up. So ladies and gentlemen, the picture is consistent. You say, how do we know? You always look at the alternate hypothesis. That inequality is pointing to the right. So this is going to give me a right tail test. And sure enough, ladies and gentlemen, I have a right tail. Let's see if the alpha is 5%. So they say use the 5% level of significance to test the claim. So all of the tail in the right is 5%. So far, everything is okay. This is our double checking. We're going to double check everything. Remember how you got that 5%. You got that 5%. You're going to get the Z. You're going to check to see if the critical value is okay. So 5% for the right tail. Remember, you worked backwards. 5% right tail. I summarized it here for you guys. We found it. 5% right tail. Working backwards with the Z. There's my left tails. I need 5% right tail. Here's 1% right tail. Here's 5% right tail. And sure enough, ladies and gentlemen, the critical value is 1.645. So we got that already. Good. 1.645 for the right tail of alpha. being 5%. So we're going to use that critical value. So I'm actually going to ask you on a test, hey, what's the critical value? And you're going to know it because you're going to go, oh, I know, it's 1.645. That is the critical value. So, ladies and gentlemen, it looks like our decision rule is fine. Remember, the critical value separates two regions here. It separates the do not reject the null region from the reject the null region. So that critical value is important. So in gray, anything smaller as a test statistic than 1.645, we do not reject the null. But anything larger than 1.645, we actually reject the null. So we're going to see how this works here, ladies and gentlemen. So these are some questions. Now, so far so good in the sense that you set up your hypothesis, you have your decision rule, and now, ladies and gentlemen, let's read further because we now have to take a sample. That's the third step. And it says a sample of 500 college students indicate that 72 completed a bachelor's degree in 4 years, okay? So I don't want you guys to feel bad about completing a bachelor degree in a certain amount of time. Don't feel bad about that. I completed the bachelor's degree. Don't tell anybody. It took me, maybe 6.5, 7 years. 7 years. So when they look at this and, we say a sample of 500, so 500 college students, that's the sample size. Only 72. There's 72 successes. That's X. That's X. It's the same as in the estimation. That's an X. That's success. 72 completed a bachelor's degree. That's going to be, as a sample proportion, let's see. That did not include Mr. Judge. He's not part of that 72 because it took him 6.5 to 7 years. He was an evening student. Started in remedial math and English courses. Okay. Just proves again, it does not matter where you start. What matters is where you end. Right, let's find that sample proportion. 72 out of 500. 72 divided by 500. 72 successes out of 500. That's about 14.4% success rate. So only about 14.4% college students complete a degree, a bachelor's degree, in 4 years. All right. What comes next is the test statistic. So again, today we're focusing on this hypothesis test about a proportion here. So this is going to be P, 1 minus P out of N here. That's your test statistics. So the sample proportion and the sample size came from the sample. 0.144, and the sample size was 500. So there you guys go. This is how we're using it. And then you need P here. Okay, and you say, well, what's P? P is always in the hypothesis. So even though you look at the null, it says P is less than or equal to 12%. Less than or equal. Less than or equal to 12%. So this is 0.12. Less than or equal. 0.12. 0.12. Like I say, write it down again. Because it's really hard to see sometimes when you try to put these numbers next to the letters. But if you write it down again, it'll be a little bit easier to see. Because you're going to have to look at this and punch this in the TI. Parentheses, parentheses, parentheses. So just to illustrate, sample proportion, sample size, to make sure everything is in the right locations. Just colorize. Okay. Colorize this. Let's get the test statistic value, ladies and gentlemen. So I always go back to the decision rule here. Your critical value is to the nearest thousand. So we're going to approximate the test statistic to the same place value because we're really comparing. Does that number live to the left of the critical value? Or does the number live to the right of the critical value? That's what we want to know. All right, let's punch this in the TI. Parentheses, 0.144 minus 0.12. Divide by square root. Second, open that parentheses. Put the 12% times parentheses. 1 minus the 12%. Close that. Divided by the sample size was 500. Close it again, and you can get out of that radical. So double check that that's exactly what we need to do. It looks like it's okay. So ladies and gentlemen, let's take a look at this test statistic. It's 1.651 to the nearest thousandths. 1.651. Double check. 1.651. So if I now go to my decision rule, 1.651 here, that's the test statistic. 1.651. Wow, ladies and gentlemen. This is why. 1.651. This is why, ladies and gentlemen, you approximate to the same place value. Is 1.651 to the right of the critical value of 1.645? Or is it to the left? Is it smaller than 1.645? Ladies and gentlemen, the test statistic, 1.651, is slightly to the right. It's slightly to the right, ladies and gentlemen. This is 1.651 because larger numbers live to the right. So this here is in the reject the null region. You reject the null. You say, no, get out of here, null. You reject the null. To be rejected, you're rejecting the null. Here's a rejection. Goodbye, null. Goodbye and good riddance. You are rejected. So remember, this means reject the null. You're in the rejection region. You just rejected the null. Okay? Now, you only have one of two conclusions. Either the sample supports the claim or the sample does not support the claim. This is your two conclusions. So go back and notice this. If you notice, when you rejected the null, you rejected the claim. You see, when we rejected the null, we also rejected the claim. And I don't have any space, but here's the conclusion. The sample, we threw out the null, we threw out the claim. The claim is out. The sample does not support the claim. So I'm going to ask for the conclusion. This is what I want. I want either the sample supports the claim or the sample does not support the claim. So I'm going to ask you these questions here. So this is what it means. Since you threw out the claim, the sample suggests that the proportion is greater than 12%. So that's what this all means, ladies and gentlemen, those details. That's what this means. The sample does not support the claim. So, this sample is suggesting that the proportion is actually greater than 12%. And that kind of makes some sense because you had a sample proportion of 14%, right? Anyway, pretty good example. I love it. Let's take a look. Here's another important idea. Let's see if there's a typo on this or not. Let's go through it. Let's see. Did I make another mistake on this? I hope I didn't. It's horrible, but you know. All right, here we go. The proportion. Oh, that's P. It's another hypothesis testing about a proportion. And by the way, all these samples are large, so this is a large sample situation. And I'm going to point that out and remind people these examples are large samples. The proportion of individuals who take a second dose of the COVID-19 vaccine, let's see what they say, is more than 92%, as indicated by the public health. And you go, Mr. Judge, they didn't say claim. I know, I took that from your book. And, you know, because some people are going to say to me, Mr. Judge, you did not go over an example that said indicated. All right. So if you're going to contact me, you go, okay, Mr. Judge, you did not go over an indicated. Is that the same as a claim? And I'll say, yes, that's the same, by the way. All right. You guys know what I'm talking about? So I want to go over that book idea because this is what people look at. And I think it's great because I think the book is great. You know, you learn a lot by reading this book. You learn a lot by reading. And anyway, the proportion is more than 92%. So what I'm going to do here is this. P, more than that's greater than 92%. That, ladies and gentlemen, is the claim. Always label it. First question on a test is, what is the claim? That's the first question. What's the claim? You got to put P greater than 0.92. All right. And so let's see if there's a typo. Hopefully not. You know, when I do this stuff, it's late. It's midnight after a long day of meetings and lecture and everything. So when I create these resources for you guys, like even now, you know, it's kind of late in the day for me to some degree. I go to bed in a few hours, you know, as an old man. So you have to look at this claim and you go, okay, is that a null or is that an alternate? That, ladies and gentlemen, lacks a condition of equality. So it's an alternate. But remember here, what you have to have is logical opposites. So this is going to be greater than, so this must be less than or equal. You have to have logical opposite statements there. So P is less than or equal to 90%. P is greater than 92%. Apologize if I said 92%. Remember the following here. Always the alternate hypothesis determines the type of test. So that inequality symbol points to the right. So you have a right tail test. You have a right tail test, ladies and gentlemen. Let's double check to see if that decision rule is fine. Use the 1% level of significance to test the claim. 1%. So 1% is in the right tail. Is the critical value really 2.33? 1% right tail, 2.33. Remember, we went through this. I went through this earlier. Right tail, 1%. Right tail 1%. Right tail 1%. The critical value, sure enough, ladies and gentlemen, for right tail 1% is, in fact, 2.33. Right tail 2.33. Critical value. So it looks like we're consistent with that. You know, so I kind of make I look at your book and I kind of make up some of these things, by the way. So right tail. So yeah, 2.33. So we're good with this particular problem. We're really good. Good. This is our decision rule, ladies and gentlemen. So remember, the next step is going to be a sample of 1,200 individuals. That's a sample size who have taken the first dose. Reveal that 998 received the second dose. So in your sample, 1,200, make sure we write this down. I always write this stuff down. Everything that I do, I show you. In other words, samples 1,200, 998 successes. So believe it or not, just because you took the first dose doesn't mean you're coming back for the second dose, evidently. I mean, that's something I've learned. It's kind of weird. You got the first dose, but not the second. Why? I don't know. Maybe people say the first dose, they got sick and they don't want to get sick again, in the same way. And I'm going to tell you guys, when I took that first dose, yeah, it knocked me out for a day and a half. I was tired and lethargic and I slept like a baby. And that's not easy for me to sleep like a baby. One of the reasons I make all these mistakes, you guys don't know, I have a health issue. I have sleep apnea. It's a health issue. And so I'll make these kind of mistakes. Don't get that sleep. Sorry about that. But anyway, when I took the first dose, it knocked me out. When I took the second dose, it knocked me out again. I'll take a third dose if it lets me sleep the way I want. Not a big deal. But evidently not everybody takes the second dose. So in this hypothesis, they're claiming 92%. I think the article I read said 93%. Anyway, we need the sample proportion, 998 over 1,200. So this sample here, let's see what the sample proportion is. $998 successes, that's the X value, divided by 1,200, that's the sample size. So this is going to be 83%. We're going to go nearest thousands, 0.832. So that's about 83.2%. Go to the thousands position. The 1 is in the thousands position. The digit to the right is a 6, so I add 1. So the sample proportion is about 83.2%. Okay. So I set up the hypothesis, I create the decision rule, I take the sample, and what comes next? I compute the test statistic based on the sample information. So I have to use the formula here, P, 1 minus P over N. So sample proportion, sample size. I'm going to repeat myself. Every time you use this formula, write it down. It helps you memorize the formula. You don't want to be looking at on a test or homework, keep looking back at different sheets. You want to be able to do it from memory. That helps with your nervousness on a test. So take a look. You got P less than or equal to 92. P less than or equal to 92%. So 0.92, 0.92. It looks a bit messy. I'm going to write it twice. Clearly write it. 0.832 minus 0.92. Square root. 0.92. 1 minus 0.92. Everything over 1,200. So I want to make sure you guys see sample proportion, sample size, true proportion, true proportion, true proportion. Put your parentheses here. And then you're going to approximate the test statistic to the same place value as your critical value, because you're going to compare where it lives, right? The test statistic, remember, if it's smaller than 2.33, we do not reject the null. And that's in the nearest hundredths. If it's larger than 2.33, you reject the null. So approximate to the same place value, hundredths, as the critical value, because you're going to compare. So we're going to put this in the calculator. I'm going to put that in the TI. 0.832 minus 0.92. That was 92%. Close that. Divide by square root open 0.92 times, put another parentheses, 1 minus 0.92. Yes, you can put 8%. Divided by 1200. Close this, come out of there, and hit enter. Remember, this is what you see here. You want to make sure. Double check. All right, hit enter. And you get negative 11.236. Approximate that to the nearest hundredths. Negative 11.24. Now, this is your test statistic value. Negative 11.24. So, negative 11.24. Where does this live on your decision rule? First of all, it's negative. So, it's to the left of 0. And in fact, it's pretty much negative 11.24. It might be way, way over here on the left. So we really, really are that far away from the critical value, the threshold. Your critical value is a threshold value. So it's negative. It's to the left of 0. It's all the way to the left. But more importantly, it's in this neighborhood called the do not reject the null neighborhood. Do not reject the null. So I'm going to write it down here informally here. I'm going to say, here's my formal information. Do not reject the null. So you're not rejecting the null. Do not reject the null. So if you don't reject the null, don't reject the null, don't reject the null, you are keeping the null. You're not rejecting. So null, you are kept. Do not reject the null. You are keeping the null. So the sample is suggesting that the proportion is less than or equal to 92%. That's what the sample is suggesting. So do not reject the null. Keep the null. If you're keeping the null, you are getting rid of the alternate, because the sample was suggesting that you keep the null statement. And if you get rid of the alternate, notice you're getting rid of the claim. Okay. You keep the null and the other one is out. The claim is out, ladies and gentlemen. The claim is out. Now, our formal conclusion, since the claim is out, the sample does not support the claim because the claim is out. So the sample does not support the claim. Goodbye, claim. Goodbye. Goodbye, claim. You are gone. Sample does not support the claim. You're gone. And that should make sense because the sample proportion is suggesting, if you take a look, the sample proportion is about like 83%. So it's saying that 83% of those who take the first dose take the second dose. And that's pretty much smaller than 92%. That's kind of what it says here, you know. So the sample is suggesting that the true proportion is certainly less than or equal to 92%, which is not the claim. So that's why our conclusion is the sample does not support the claim. Okay, let's take a look at the next question, the next example, and let's see if it's going to be something that is, let's see if there's a typo. And notice, let's notice this. Let's see, there could be a typo. Because when I created this, I was tired and asleep. What does it say? Let's be careful here. At least 35%. Oh, that darn book. You know, with this new edition, they add that phrase, at least 35. They always change a little something in every edition so they can sell a new text to you to get top dollar. So 35% is a proportion. So you go, oh, okay. At least 35% of insomnia sufferers who are treated with this drug have increased their sleep time significantly. As, they use the word claimed, as claimed by a drug manufacturer. Okay. Increase. Then I got to figure out, what do they mean by increase? Well, here's what they mean. The proportion, at least. Remember this phrase here. At least 35 is greater than or equal to 35%. So this is my claim. H0, H1. So at least 35%, that's what they're doing to you. So I have to look at this and go, is that a null or is that an alternate? Because it has a condition of equality. And what I'm going to do here is I'm going to put it like that and see if we can move it. Remember, I'll put claim right here next to it. Okay, now what happens next is the null and the alternate have to be logical opposites. So greater than or equal, less than P and 35%. So sure enough, ladies and gentlemen, H1 less than, it's a left tail test. So we are correct with this. All right, so remember, if we finish reading, they're going to tell us to use the 10% level of significance. So 10% is in the left tail. Let's double check. Is the critical value negative 1.28? 10% left tail? Is that my critical value? Well, we worked on this earlier. 10%. 10% left tail. Let's find that. 10% left tail, 10% left tail. There, nope. 1% left tail, 5%, and here we go. Here's negative 10% in the left tail. They're saying it's negative 1.28. We worked on this earlier. Negative 1.28 here. Okay, 10% left tail, negative 1.28. That's my critical value. So let's double check. Negative 1.28 critical value. And sure enough, we do have the correct critical value. So this is my decision rule, ladies and gentlemen. This is going to be what we use, that decision rule, negative 1.28. So the next portion is going to take the sample. We go, okay, it says a sample of 120 insomnia sufferers who were treated with this zopiclone indicate that 42 increased their sleep time. So 42 successes. We have a sample size of 120 with 42 successes. This is the X and this is N. So I write that down. I say, okay, here's from my sample. Sample size was 120 and we lost, you guys, and let's get you guys back. So let me get you guys back here. Okay. Screen share. It's a screen share. Welcome to technology. Screen share. So come on back. You'll be back. 5097 is the code. And you guys are now back. There we go. Apologize. Let's go back here. N is 120. X is 42. 120 sample size. 42 successes. They increase their sleep time. So I say X is 42. So the sample proportion will be 42 out of 120. And your sample proportion, 42 out of 120. Let's see what that is in the TI. 42 divided by 120. This is a 35% sample proportion. 0.35. Okay, good. We needed that. And after we take the sample, we compute the test statistic. Sample proportion minus the true proportion, square root of P, 1 minus P over N. So the sample proportion here is 35%. This comes from the sample. The sample size is 120. Okay, good. We just have to know what P is. P greater than or equal to 35%. P goes here, P goes here. So P 0.35, 0.35, 0.35. I write it twice. And so if you notice, you say, Mr. Judge, that's 0.35 minus 0.35 over what? Square root of what? Let's be careful here. 35%. I can do the complement already. I know it's 65%. Complement of 35 is 65 divided by sample size of 120. Now, I'm going to tell you guys a little something. This is interesting here. Okay? The true proportion is 35%. That's P. The sample proportion was 35%. If anybody knows, what's the difference here? The numerator, 35% minus 35% is 0. 0 divided by any number is 0. So I don't have to use a calculator to know this. Okay? If my numerator of a fraction is 0, I don't even care what the denominator is, because 0 divided by any number is 0. So the test statistic here is equal to 0. So my test statistic is right here at 0. So remember how this works here. Okay? Any test statistic that's to the left of my critical value of negative 1.28. Any test statistic to the left, in this case it was 0. We do not reject the null. So because it's to the left of negative 1.28, the critical value, test statistic equals 0, I know I'm not going to put it right here, I guess. We say do not reject the null. There's a C there, so let me do not reject the null. So you say do not reject the null. Now remember, if you don't reject it, you are going to keep it. So do not reject it, you keep it. Do not reject, you keep. You're not rejecting. So you go to the null and you say, guess what, null? You are not rejected. You are kept. Do not reject the null. Keep the null. What does that mean about the claim? Remember what we said. There's only two types of answers you guys have here. There's only two answers. Go all the way back here. There's only two conclusions. Either the sample supports the claim or the sample does not support the claim. So, ladies and gentlemen, here we go here. Let's answer that last question here. Okay. Here we are. This is it. What happened with the claim? Was the claim kept? Or was the claim discarded? Like here in the last example, we got rid of the claim. But over here, by keeping the null, we are keeping the claim. The sample supports the claim. Now, this is an answer I'm going to be looking for on a test. I want to know either the sample supports the claim or the sample does not support the claim. That is your conclusion, okay? So typically on a test, here's what I ask. What's the claim? Question 1. Question 2. What are the critical values? Question 3. I might ask, what's the sample proportion? Question 4, what's the test statistic? Question 5, what's the conclusion? So everything for the most part that you guys see here is what I'll ask for a hypothesis testing question. Now this is hypothesis testing about a proportion. I wanted to make a video for you guys because I had that request, remember? People say, can you go over some of these things there? Yes, I could, and I did. So we got this clarified for you guys. It's good. Now, next time, to do the rest, you have hypothesis testing, not about a proportion. So in our next lecture, we're going to go over hypothesis testing about a mean. And that mean is mu. That's the next lecture. And you say, Mr. Judge, how does that work? I'll say it works the same way. The only difference, though, and this is for next time, the only difference is you're not going to compute or use the test statistic for testing a hypothesis about a proportion. Next time, this will be our test statistic. So next time we're going to look at this. This here, sample mean, sample standard deviation, sample size. So this will be our test statistic for next time. And mu is the true mean. Okay, so stay tuned, everybody. Stay tuned for next time because, that's coming. So anyway, have a great weekend, ladies and gentlemen. And I enjoyed doing this video for you guys as slow as possible to go over the details. Take a look at this, but this will be next time, okay? Have a great weekend. Take care. Happy Mother's Day.